save. All right, so right now we have this equation that we're going to solve, negative 10 y minus 7 squared equals negative 360. So I am going to start here by dividing both sides by this negative 10. This thing in front needs to go away. A negative 360 divided by a negative 10 is going to be a positive 36. And if I didn't last time, I'm going to apologize for my handwriting. It sucks. But we're all stuck with it. Then, in order to get rid of this squared, since this is one thing squared, one term squared, I can just square root both sides. So over here, the square root and the squared cancel. And over here, I have the square root of 36. Now, the square root of 36 is 6. But this question is not asking me what is the square root of 36. It is asking me what, when I square it, is 36. And there's a big difference between me asking you what is the square root of 36 and what, when squared, is 36. Because the square root of 36 is 6. But a number that squared is 36 can be either 6 or negative 6. So in the context of solving an equation like this, you always need to remember when you're taking the square root of both sides that you need that plus or minus. Because again, I'm not asking you for the square root of 36. I'm asking you what, when I square it, would give me 36, and that's why we need the plus and minus as well. Now, the last thing I'm going to do is add the 7. And so I have 7 plus or minus 6. So then that would be two answers, 7 plus 6 and 7 minus 6. So that would be 13 and 1. And so if you look right here in the instructions, it says separated by a comma. So we would do 1 comma 13. And now since these were integers, no decimals, you're just going to put the exact same thing here. Okay?
Just a quick question.
Yep.
I'm not sure sometimes in other classes I've had teachers prefer that we put them in order. So instead of putting 13 comma 1, you kind of want to put it in that order, right? So if you have a negative 5 and a negative 1, it's going to go in that order and not the other way around.
True. Now, this is where I would say, and again, keep in mind that this is a different format than I've ever had in. This is where I would say, yes, you're right. Mathematically, the correct way to do this is to write them in numerical order. I will always write them in numerical order. For me, if you were to come to me and tell me the answers are 13 and 1, I wouldn't say, no, that's right. The answers are 13 and 1.
So it's just better to get into the practice of doing that.
Right. Now, there absolutely are teachers out there who are going to be anal retentive and say, no, they're not. They're 1 and 13. But that's not like who I am as a human, if that makes sense. Like, the answers are 13 and 1. And mathematically, should you write that as 1 and 13? Absolutely. But if you and you don't have written tests. So this is where I would have said, but if in the test you wrote 13 and 1, you'd still get full credit. But now in Moore, I'm honestly not sure. So I honestly don't know if Moore would take 13 and 1 or if it would only take 1 and 13. I never checked.
I feel like it's a hit or miss.
So
sometimes they want it, sometimes they don't.
It's probably good practice to write it in least to greatest order, just because I'm 100% sure that it will always accept that.
Why? So I just did a math class last semester and we already went over this, but why are we doing like where we have to use a calculator type of thing? I feel like the videos kind of confused me because like, is he looking for a different answer than team?
No, I think when Andy goes over the calculator with you, I think he's just trying to give you another extra way to solve it. If you've never if you were never aware of the fact that your calculator could do that, this still works.
Okay.
Moore doesn't know how you solve things. So even if Moore said, hey, factor this, and you use the quadratic formula, it wouldn't know.
Yeah, because that threw me for a loop when I was doing it.
Yeah. So, and again, this is just me as a person talking to you. In my opinion, if you know a good way to solve something and you I know personally of 3 different ways to factor quadratics that are all completely different, but all get you to the exact same answer. If you
Okay.
know a way and you are good at it, then do that way. Like, just because I say factor by grouping, if you're better at the mistake method or better at whatever else, if you learned it a different way, if you prefer to do guess and check, if whatever, and your way works for you, then do it your way. It's always been the way that I've run things. So when Andy shows you that you can put this stuff in the calculator, know that that's just a tool that he's giving you to put in your toolbox. If you prefer to just straight solve this, go for it. I would say maybe straight solve it and then check in your calculator to be like 1,000,000% sure that you got it right, especially because on your tests, you're only allowed 1 submission per question, which is nutty, but that was not my choice. So then that way, if you do this by hand and then you use his method to check in the calculator, then you can walk away from this question 100% sure that you got the answer right. Does that make sense?
Yeah.
Okay. This one is going to be very similar. It's just a little bit more involved, so I thought I would add it. But here, I feel like sometimes we're going to be tempted to subtract the 6 and 8, but we can't do that because the 8 is attached to this parentheses. And so it would be like if we tried to subtract these 2, you know that you can't subtract those. If you have a number touching a parenthesis, then that means that it's the same, it has the same type of thing going on as this, as if it was touching a variable.
Okay.
So the first thing we need to do here is subtract the 6 to get it away. Eight, so that would be 384. Does that sound right? Then we're going to divide by the -8. -48. So -8 divided by -348 is a +48. Then just like above, we're going to take the square root of both sides. Now, I'm going to subtract the 5. Then I'm going to divide both sides by the 8. And then once I have an answer like this, the last thing that I have to do is a very similar step to what I did up here, where I have to see if I can reduce this at all. So the square root of 48 would reduce. So there are 2 ways to do this. You can do a factor tree, or you can just ask yourself, are there any perfect squares that go into 48? So do we know any perfect squares that go into 48? We do. 16 goes in 3 times. And then I choose perfect squares because the square root of 16 is 4. So then that means the square root of 48 is the same as 4 square root of 3. And then the last thing that we do to see if we can reduce this is we cover up that square root and we ask ourselves, is there a GCF of all of the numbers that we're looking at? And in this case, there is not. So that means that we're done. Now, when you're putting this in more, you're going to want to do the numerator in parentheses. So -5 plus this 4 square root of 3 divided by 8. like that, comma, parentheses, -5 minus 4 rad 3 divided by 8 like that.
Hey, Jess.
Yeah.
Quick question. So I'm kind of stuff is coming back from one of my last classes. So we have that 8 under the -5 plus or minus 4, but doesn't the, okay, the 4 is attached to the 3, and because it, I feel like the 4 and the 8 can be reduced, or no, because it's attached to the root 3?
It's not that it's attached to the root 3, it's that I'd have to be able to take something out of all 3 of these. And there's nothing I can take out of the 5, the 4, and the 8.
Okay, never mind. False
Okay.
memories.
Totally fine. And so they want 4 decimal places. So -5 plus 4 rad 3 divided by 8. 0.2410. I don't know if you know this, but if you do second and then enter, it brings back the last thing you typed in. And then that way you can just go back here and change this plus to a minus. Boop. 1.4910. And again, more might insist that you do this -1.4910, comma, 0.2410. I don't know. But there it is. Okay. So x squared plus 15x plus 56 equals 0 for any quadratic in this form where you don't have like a unit squared or you do have a bx term. And I apologize for those of you who just took 121. This is probably sounding incredibly redundant, but that's what it is. You need to get this equal to 0 before you can solve it. And at this point, we have 2 options. We can either factor or we can use the quadratic formula. I always like to check to see if I can factor first because factoring is a million times easier. So when I check to see if I can factor, I make a t-chart, and that t-chart is the factors of c. If you have an a value, if there's a number in front of the x squared, then you multiply that times c, and then you make your chart with that number. If there's no a squared, then you just use c. If there's no a term, excuse me. So the factors of 56 would be 1 and 56, 2 and 28, right? Yeah. Yes. 56 divided by 3. Nope. 56 divided by 4. 4 and 14. 5, no. 6, no. 7, no. Yeah, 7 and 8. 7 and 8. Okay. And then the way that my factor chart works is that as soon as you come around to the other side, you've finished. So 7, the next thing I would test is 8. I don't need to test 8. It's already in my list. And then I want to know, is there any pair of numbers in this list that add to my B term? And in this case, there is 7 and 8. And so when we don't have an A, that's when we can just say that this is x plus 7, x plus 8, and then x plus 7 equals 0, x plus 8 equals 0, -7, -8. So factoring. Factoring is one of my personal favorite things to teach because it's a process, and once you get good at that process, you're done. However, 16 times 27 is 432. I mean, we could check this one. 16 times 27 is negative 432. We need to add up to 66. So that's 1 and 432. 432 divided by 2. 2 and 2, 16. Divided by 4. 5 doesn't go in, but since both 2 and 3 went in, then that means that 6 goes in. There it is. Those would be my two that make a 66. Because if they have to multiply to a negative 432, then that would be a negative 6, and a positive 72 would multiply to a negative 432 and add to a positive 66. I'm going to put an asterisk on this and tell you that if you did the quadratic formula, that's perfectly fine with me. Because I think in his notes, in his examples, he did the quadratic formula for all of these, right? He didn't factor any of them. I remember watching that and being like, all right.
He did factor it. He said, you know, do the quadratic formula if it seems like any of them are going to be too tedious or you can't break them down. But I mean, the truth of the matter is if you do the double bubble, it might take you as long as just, you know, doing the quadratic because you're looking for those factors that go into that negative 432.
That's very true.
Either way it works. You're always looking for the quickest method, but if it works, it works.
This could be tedious, and if you hate this, then don't do it, then do the quadratic formula every time. I have no preference. You're not hurting my feelings if you don't factor. So 16x squared and a 6x have a, I factor by grouping every time. Just like I said earlier, if you have a different method that you prefer to factor by, go crazy, but know that my preferred method of factoring is by grouping, so that's how I'm going to do it in my examples. 16x squared and a 6x have a 2x in common, and that would leave me 8x minus 3. 72 and a 27 have a 9 in common, and that would leave me 8x minus 3. So then this would be 8x minus 3 and 2x plus 9. Now, I'm going to say for right now, when you're solving these, if you don't want to factor, you don't have to. You can use the quadratic formula all the time. But there's going to be a point later in this semester where I'm not asking you to solve. You will have to factor in order to be able to do things like reduce radicals or reduce rationals. So factoring is a skill that you need. So if you do not know how to factor, if you do not remember how to factor, please make sure that you review that, because there will be a point in this semester where you have to know how to factor, where you can't use the quadratic formula because you're not trying to solve. You're trying to reduce. And in that case, you will need to know how to factor. Okay? There we go. So negative 9 over 2, 3 over 8. I don't know why I almost wrote 8 over 3. And then we need decimals. Calculator just turned off. 3 over 8, 0.375. That's going to be the second one. Negative 4.5. I feel like I knew that one. You know that moment where you're like, why am I putting this in the calculator? I know what this is. It's a decimal. And you're still putting it in the calculator while you're asking yourself that question. That was me right now. Everybody good? Okay. So for this one, again, we're going to move that t term over. Now, a side note that we should always be keeping our squared term positive. So we should always move things so that our squared term stays positive, because having a negative squared term will mess up all of your signs later. So try to always keep that squared term positive. So I'm going to add this t over. And then I would multiply the 2 times the 9. That's 18. I'd have 1 and 18, 2 and 9, 3 and 6, 4 no, 5 no, and I'm at 6, so my chart is done. There are no two numbers that multiply to 18 and add to 1, so this is the case where I would have to do the quadratic formula. And we all watched the video, so we all had him review it for us. Let's write it down over here real quick. Negative b plus or minus the square root of b squared minus 4ac over 2a. That's a thing that you need to know. I mean, normally I would be telling you that you absolutely have to have it memorized, but all of your tests are online, so. Should you still memorize it? Yes. Will you die if you don't? No. So that in this case, my A is 2, my B is 1, and my C is 9. And so then this is an X, it's T. T equals T equals negative B, so negative 1 plus or minus the square root of 1 squared minus 4 times 2 times 9 over 2 times A, which is 2. Is that right? Okay. I'm asking because I genuinely mess up sometimes. So I need you to be on top of me. And if I make a mistake, please tell me. Minus 1 squared is 1. 4 times 2 is 8. 8 times 9 is 72 over 4. So T equals negative 1 plus or minus the square root of negative 71 over 4. And remember, we can't leave that negative under the radical. So T equals negative 1 plus or minus I rad 71 over 4. So now, you were asking before about putting this in the calculator. Is that correct? Who was asking? No. I know I'm not going crazy, guys. So then put this in up here like this. Negative 1 plus.
Annalisa, you have to unmute yourself.
Oh, is she not? Sorry.
No.
I just raised my hand.
Oh, see, when I'm screen sharing like this, I can't see the list of you guys. So I'm sorry. So like I can't even see that you're raising your hand when I'm screen sharing. I apologize. That's probably why it's better if you just unmute yourself and say something. 1 minus I rad 71 over 4 plus I've got to get used to this whole like, I don't know, looking. Normally people are raising their hand and my eye is drawn to it because we're in the same room. You know? Anyway, so then if we're putting this in our calculator, was that your question, Annalisa?
Yeah.
So if we're putting this in our calculator to get a decimal approximation, I'm going to say negative 1. I'm going to put my parentheses, negative 1 plus, and then the I is right down here, second, and then your decimal point. See it?
Yeah.
Okay. So the negative 1 plus or minus I rad 71. Oop, I put my parentheses in the wrong place. I forgot to press over 1 to get out from under my radical. Divided by 4. So that would
Oh, okay. What I'm doing is when I put that in, I'm not pressing over after the radical. I'm just putting the parentheses. So like everything's carrying. Because the one I have is a fraction like this, the answer I have, but like I couldn't figure out how to.
Yeah, that's what happened to me yesterday.
we texted it.
This is Alex. So with this one, I think they want you to just put NR
Oh,
if it's not real.
oh,
Yeah,
you're right. NR. Thank you, Alex.
no problem.
Alexander. Sorry. NR.
So anything with an I is going to be not real.
We did more than we had to. Yeah, look, it says it right there.
So how do you know it's because it's the still the quadratic thing?
Because of the I.
Oh, okay.
So an I makes this complex. It takes it out of the real number system and puts it into imaginary numbers. And so anytime you have an I, then that means that you're not real, and all you're going to type in that second box is NR.
Okay, I thought we had to solve this because the guy in the video, he still plugged it in. So,
Oh, did he? I watched those videos a while ago. I probably should rewatch them. I'm sorry.
so then if we did just do NR, then we're good.
So if you get an I, then just put NR in that bottom one. But now you know how to put it in your calculator, so there's that.
Thank you.
No problem. All right. So then on the next one, again, I have like a mess going on here. I'm going to put everything over to the right side here because I see that I have more x squareds on this side and I want to keep my x squareds positive. So I'm going to move this 5x squared over. I'm going to move this 5x over, and I'm going to move this 9 over. Minus 5x squared plus 5x plus 9. So then what I have is 7x squared minus 5x, that's 2x squared. Negative 4x plus 5x, that's going to be a 1x. And then a negative 18 plus 9 is going to be minus 9. This looks suspiciously like the question above it, only my last number is a minus instead of a plus. Okay, so what that tells me is that I already know I can't use I can't factor this one because I just tried the 18 and 1 and that didn't work, so I'm going to jump right to the quadratic formula. X equals, here we have A is 1, B is 2, and C is negative 9. Again, very similar to the one above, but that C is negative, but we're going to see that that's going to make a huge difference in my final answer. That one negative is going to change everything. Wait, these are backwards. Caught it. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 9 over 2 times 2. So then that's negative 1 plus or minus the square root of 1 squared is 1. Now this time I'm going to have 72 again, but a negative 4 and a negative 9 is going to make it plus 72 over 4. So x equals, oof, my pencil broke. Negative 1 plus or minus the square root of 73 over 4. 73 is
Jess?
9. Yeah.
Sorry, quick question. Isn't your A and B supposed to be negatives and your C supposed to be a positive?
No, I moved everything around so that my A was positive. So if all three of your signs are the opposite of mine, it's because you moved everything to the left and I moved everything to the right.
Oh, okay.
We'd get the same answer in the end. P.S. Like you would just have a positive 1 and a negative 4. Is that correct?
Yeah.
But that's the same because 1 over 4, if it's negative 1 over 4, it's negative 1/4. If it's 1 over negative 4, it's negative 1/4, right? So whether that negative ends up in the numerator or the denominator doesn't really matter in the end, except that in math, we're not supposed to have negatives in denominators, which is part of the reason why I tell you to always make sure that your A term is positive, because we know that A term is going to go in the denominator when we use the quadratic formula. So we want to try to keep that positive. What we don't know, Ramon, is whether or not more would accept it if you had the negative in the denominator. It might not. I don't know. I've never tried it with the negative in the denominator. So then this would be negative 1 plus the square root of 73 over 4, negative 1 minus the square root of 73 over 4. Parentheses, negative 1 plus the square root of 73. Remember to hit that over button. Over 4. And then again, that was second enter that pulled up that last line. And then I just changed the plus to a minus. So negative 2.3860 because they want 4 decimal places. And negative and positive 1.8860.
So just a refresher for myself. So say I got something like at the end I have like 2 plus minus radical 25, like at the end of my answer. I can pull the 5 out of that 25 and then we could just add the 2 and the 5 and subtract the 2. Okay.
Absolutely.
Thing like that doesn't have, I don't know the verbiage for it, but like, 5 and 5 is 25. But if it's something like the 16 and 3 that you did before, that's when we actually like do the whatever, break it apart. Okay.
So if you get a perfect square, if you get something like 25, then that means that you could have factored,
Okay.
but didn't. And that's fine. But then you do absolutely need to like take those steps to reduce, because if you put -1 plus or minus the square root of 25 up here, I don't know that it'd give you credit. And then you'd put it in your calculator down for this step and you'd be like, oh crap, that was a whole number. Right? What you need to think about is the ones like we did before that you can reduce. So yeah, if you can reduce your radical, then you absolutely should.
Okay.
Okay. All right. And now, again here, I'm going to look to make my z term, my z squared term positive. So if I have a negative 2.06 z squared and a negative 0.49 z squared, to come out with a positive z squared, I would add this 2.06 to both sides. And so since I'm moving the 2.06 to the right, I'm going to move everything else to the right as well. He put this one stupid question with all these decimals on here just to be annoying, I think. Don't tell my boss I said that. So 2.06.
And also, can we stop using T's and Z's as variables?
I know, right? So 1.57 z squared. And then I have negative 9.95 plus 6.16. So negative 3.79. Oh. Z. And then I have 7.09 minus 8.07, negative 0.98. Okay, so A is 1.57. B is negative 3.79, and C is negative 0.98. There is some kind of ridiculousness going on in my house right now because I just heard my daughter like squeal from across the house. They must be having fun out there. Okay, so Z equals plus or minus, no, Z equals negative B. I don't know why I keep on doing that tonight. Negative 3.79 would be a positive 3.79 plus or minus the square root of negative 3.79 squared minus 4 times 1.57 times negative 0.98 over 2 times 1.57. 3.79 plus or minus. Now, I am going to take the whole radicand, that's the thing under the radical, and I'm going to put it in the calculator all at once because why not? 3.79 squared minus 4 times 1.57 times negative 0.98. See, it's just all of this at once. 20.5185. Now, a quick note that remember that if you have a negative number and you square it in the calculator, you need parentheses, because if you do negative 3.79, and I'm going to do it with an easier number, if I do negative 5 squared in the calculator, it does order of operations, so it's going to do this. It gives that negative the same precedence as multiplication. So this is basically the same as negative 1 times 5 squared. So it's going to square it and then make it negative. In order to tell the calculator not to do that, you put it in parentheses. Okay, so somebody has probably said that to you at some point, but just in case they have not, in your calculator, if you have a negative and you're squaring it, always put that negative in parentheses. Okay?
Technically, as like a shortcut, we could just make it positive.
I mean, really, you could leave the negative out because you're squaring it. It doesn't matter in that one case. But just in case, like, I still want you to know that rule. Okay? Over 2 times 1.57, 3.14. Jeez. I'm honestly not sure if Moore would let you put this in like that. I don't know if it'd let you put the decimal. Has anybody tried these yet? Oh, okay. It just wants your decimal answer. Okay. It doesn't need the exact. Perfect. I was like, if it wants exact, I don't know, whatever. Good news is that they realized that that would be a really stupid thing to ask you to do, so they didn't. 3.79 plus the square root of 20.5185 divided by 3.14. What I was saying was the exact answer for this is not the way that it's written down is not the exact answer, because you can't have decimals inside of fractions. So we would technically need to multiply everything to get rid of those decimals, and that would just be annoying. So fortunately, they did not ask for exact answers here, which is good because I didn't want to have to figure that out. And then second enter and change this to a minus. So 4 decimal points again. Yep. So negative 2.356. That's going to round up to a 2.356. And 2.6496 as well. That's also going to round up. So negative 0.2356 and 2.649.
Can you do the enter thing again on your calculator? Because when I did enter, I can't figure out how to like go back in and.
It's not enter, it's second enter.
Oh, that's what it. Okay.
So second and then enter will pull up the last thing you typed.
Okay. Thank you.
Got it?
Yeah.
All right. So that was what I had for 1.0b. That one's way more intensive than 1.1 is, which is the good news. So 1.1 is, I think, IMO is an easier section than 1.0b. So in section 1.1, you should have been doing a review of what is a function and function definitions and stuff like that. So keeping in mind that the definition of a function is also the best piece of life advice that I can hand to all of you listening to me right now, and that would be no repeating x's.
What now?
The definition of a function, the definition of whether or not something is a function, is also my best life advice to you, and that is no repeating x's.
Ah,
Thank you for laughing. I appreciate that. It's my best joke all semester. So,
I'm using math terms, not.
so if we have a table of values, whether that table of values is horizontal or vertical, You just want to look at your x's, and if all of the x's are unique, then you have a function. So for example, the y values do not matter when we're deciding whether or not something is a function. So I would say, yes, this one is a function. I would say, no, this one is not a function. And I would say, yes, this one is a function. Okay? In that order. And now, the super small script on this says that if you have a function for population and the amount of garbage they produce, P is measured in thousands of people. A town with a population of 45,000 produces 14 tons of garbage. Oh, G is measured in tons. Okay. Then they want to know, express this in function notation. So keep in mind that function notation is y equals f of x or f of x equals y. That is function notation. So what they want here is they want to know that P of 45,000 people produces 14 tons of garbage. That's all they're looking for on that question. And I know that it's 45 because it says thousands of people, and that was 45,000, so I only want the 45. And I know this is 14 because it said 14 tons, and that was in terms of tons, so that's what I want there. I feel like when I was looking at these, I was like, what are they looking for on this question? And then I hit show the answer, and I was like, well, that's dumb. Okay. Thank you for making it sound a million times worse than it is. And so if we're given a function and asked to find values, all we have to do is plug in. So if we have k of a is 6a squared minus 4a plus 4, and we want to know k of negative 5, then that means that we want to know 6 times negative 5 squared minus 4 times negative 5 plus 4. Which is 174. And so I'm not going to do all of these for you. They're all the same as this. You would just plug in negative 4 or plug in 0, put it in your calculator. Whatever your calculator shows you, that's what it's looking for.
I'm getting that answer or that question wrong on the homework.
Which one? This one?
Yeah.
This one? Try to flip them around.
Oh no, it's because I put P of 30 instead of G of 30.
Oh, okay. Yeah.
Well, how are we supposed to know which one we're looking for?
So it's all about the wording. And I would just, if one doesn't work, try the other, because these are not worded super well. And if that doesn't work, then try to flip the numbers.
Okay.
Again, this is not worded in such a way that like is inherently obvious. So try both letters, flip the numbers if you have to. One of those will be right, I promise.
So this isn't on the test, I'm assuming, because we only have maths.
It shouldn't be. I'll check.
Okay.
So we're okay with this, right? I don't need to do more of those because I shouldn't have to. Now, this one is a little bit different because they didn't give me x, they gave me m of x. I'm not going to put 12 in x. I'm going to put 12 in for m of x. And I'm going to say that this is 12 equals 3x minus 5. And I know that that seems like duh, but you'd be surprised how many years I've been doing this and how many people make that mistake. So notice again that they didn't give me x, they gave me m of x. So I'm not going to replace x, I'm going to replace m of x. And then solve, add the 5, divide by 3. 17 over 3. 5.1, 2, 3, 4. Okay? So make sure that you're watching and you're paying attention to whether they're giving you X or whether they're giving you Y. Because in this case, they gave me Y. All right? It's going to be the same thing here. They've given me X. So I'm going to go into the X line and look for 25. And when X is 25, Y is 23. But here on the next one, they've given me Y. So I'm going to go into the Y line and look for 24. And when Y is 24, X is 17. Okay? So you just have to be super cognizant of what they've given you and what you're looking for. All right? No, I should have marked which one of these was the front. I think this is the front. So on a graph, again, we're going to do the same thing. Here, they've given me X. So I'm going to go to 4 on the X, and I'm going to go up and find where on the Y that is. This is the 0.42. So that means when X is 4, Y is 2. And then for this last one, this time they've given me Y. So I'm going to go to where Y is 3, and I'm going to find the point. That is the 0.13. So when Y is 3, X is 1. So with all of these, it's super important that you are paying very close attention to what they have given you. Have they given you X or Y? That way you know what you're looking for. If they've given you X, then you need Y. If they've given you Y, then you need X. Okay? Because that's
Hey, Jess,
where most of you guys make your mistakes on these.
Jess,
Yeah.
it looks like I printed up the in-class notes, and did we skip a page for the
Yeah, that was the
following
back side
graphs,
of it.
which represent Y as a function of X, and for the following graphs, which represent a 1-to-1?
Just
That one.
wrong order, sorry. I printed them, you know, I need to put page numbers on these or something. So this is my first one through this class, like I was telling you guys. And so I pulled these examples and it didn't occur to me to put page numbers on anything. I just printed them and then grabbed them and they got out of order. So I apologize. So do you remember how to tell whether or not something is a function?
I remember the line test.
The vertical line test, exactly. So that means that if there is no vertical line that would touch the graph more than once, then it is a function. So I would say
Because we don't want the repeating X's.
exactly. Yes, this is a function. No, yes, yes.
Say that again, because I got every single one of these wrong.
So if something is a function, now again, just like with the last ones I was telling you, you have to be really cognizant of what they're looking for. If they just say function, then you want to pass the vertical line tests. Do you remember the vertical line test?
Yeah, I wrote the definitions of that, but I thought I was answering them right. So on this one that you just did, it can't touch the line more than twice?
It can't touch the line more than once. Can't touch a vertical line more than once.
Okay. Oh, so obviously the second one isn't because it's not going to touch it at all.
Because it is a vertical line. So. And then for something to be a 1-to-1 function, it would have to pass both the vertical and the horizontal line test. Test. Where the vertical line test tells us, is it a function? And the horizontal line test tells us, is it 1-to-1? Now, a reminder from Andy's lecture, I know that he said this, but I'm going to repeat it. A function is 1-to-1 if all of the y's are unique as well. So in order to be a function, all of the x's have to be unique. In order to be 1-to-1, all of the y's have to be unique as well. So this line is the perfect example of a 1-to-1 function. There is no vertical line that it would touch more than once. There is no horizontal line that it would touch more than once. This absolutely is a 1-to-1 function. Now, for this weird squiggly thing, while it would pass the horizontal line test, it would not pass the vertical line test. So it is 1-to-1, but it is not a function. All of the y's are unique on this one, but the x's are not, and therefore we would say no. And so then on this exponential, it would pass the vertical, it would pass the horizontal, so yes. And on this rational, it would pass the vertical, it would pass the horizontal, so yes.
Oh, that was really easy. And I struggled for like 10 minutes and I was like, I'm just gonna wait.
Well, I'm glad I was able to make it easier for you.
Thank you.
Does anybody else have any questions about these?
You said you're gonna post this video on Canvas.
I am going to try. That is always the goal.